developed his career, that is Pedro Lorenzo, in Europe and the USA, commanding positions in the academic field, public sector, and private sector. Pedro, you have the floor, and we're going to try to adjust to the 10 minutes we have. Thank you. Right, good day everyone. First of all, I'd like to thank the organization for this event. It's sheer luxury to see that this event is increasing every year. We hope that trend will continue. And I'm here to speak from Econward. We do pre-treatment solutions for anaerobic digestion based on thermodialysis of organic fraction of solid urban waste to adapt that waste to digestion and to do good treatment and reuse it. So within that framework, in this presentation, I was going to speak about a EDAR project we have, where we make remarkable increases in biogas production from codigestion and modelized FORSU. So we actually developed a technology called biomac, which is a termohydrolysis technology for the organic fraction of the waste. And hereafter, we managed to recover it efficiently. At the beginning, thermohydrolysis is basically applying pressure and temperature during some time to the waste. That technology is quite well known in water treatment plants, and what we do is apply that technology for materials with high solid content, such as the organic fraction of the RSU, or even their rests from pruning or watering or any other waste flow that may be treated, because we hydrolyze all the biodegradable fraction but not the unsuitable elements. So which are the results of the thermohydrolysis? Well, the material is much more homogeneous and easy to treat within digesters. We managed to get chemical degradation. We break complex molecules into simpler molecules to produce more biogas and more quickly, and we eliminate pathogens from material due to the temperature. So that allows us not to have competition from the bacteria in the digester. As a result, we have an improvement in digestion efficiency quite considerable. Apart from that, better ability to separate unsuitable materials from that origin waste, because all the organic matter is made soluble, and we can include that material and generate quality substrate. It's not an R&D project. What we have is a real plant located in Madrid, and here you may see one of the models of our equipment with a treatment capability of 8 tons per hour. And here we're treating waste. We hydrolyze, and with a 20-minute retention time, we adjust the operation parameters depending on the organic fraction we're treating. That is a 4-autogy semi-continuous system for a high content in solids, so from 20% of total solids and above. So an image is worth 1,000 words, and that's typical ways to treat, in this case, the separate collection from Madrid. Even though we insist on the fact that separate collection is great, luckily, we're seeing that after years of separate collection, there is still a 25% of unsuitable materials, which is a big problem for these digesters, making this material hard to treat. So our solution, hydrolyzing the material in favoring good mechanical treatment, is to generate a type of substrate where all the organic matter is recovered, and that has the qualities to be a good additive for plants exclusively for FORSU treatment or other digestion plants. So this is the setup we had, scaled industrially, with the Clamber Technological Center and with the municipality of Madrid, where we get directly the waste. We can hydrolyze it, make the mechanical separation that we spoke about, and we generate quality substrate to feed the digester and favor better biogas production. For material that initially could not go to the digester and a digest at the same time. So once proving this concept and seeing all the economic benefits it has, we thought, well, why should we not apply this same model and install it in water treatment plants, generating co-digestion with treatment sludge. So we got the sludge together after the thickeners, and we saw that that could make sense. So the current framework has several elements, including a high organic fraction, and we are forced to collectively collect this fraction, which already exists. What does not exist are the plants to treat it. We know there is potential, that many things will happen, but they do require years until it is proven that these plants will be operating, and that group of waste needs to have an output. So we saw many co-digestion solutions in other countries, so success cases, and we said, well, it is a direct application to generate that substrate, and there are existing plants where we may integrate it. So we made a project that began back in 2020. It is scaling up from lab, going through lab tests and semi-continuous tests to an industrial plant in 2022 to set the parameters of everything we were thinking about. So first we tried to optimize the mixtures and look at the percentages of thermalized FORSU that was right for digesters. And the simplest operation, less costly for these plants, and of course to quantify how much extra biogas we were producing and how efficient this was for wastewater treatment plants to add our substrate. So we did many tests and analytic trials. I will not bore you with this, but we saw that with a small percentage of additives between 0 and 20% of thermohydrolized material, the operation conditions of digesters for water treatment really improved. So let's check the results directly. And what we saw is that the increase is extremely big, really. By adding a little amount of hydrolyzed FORSU, and here we're adding more FORSU up to 20%, and their increases actually treble the existing production of biogas in this plant. So we kept developing and looking for figures, and to our surprise, we saw the following chart, where we see that there is no linear increase in the biogas production regarding the percentage of FORSU added. What we saw was an exponential increase, that the maximum levels were between 15 and 20% of adding thermohydrolized FORSU. The top line represents the theoretical maximum, and on the left we have what is generated by a sludge plant, and on the right we have the percentage of the added FORSU in a plant. And here we have a synergy effect. So the sum of the two productions independently is lower than the synergy produced due to the feeding of carbon to a nitrogen digester to produce much more gas. So directly, if we go to the conclusions, from the perspective of products, first, there is much more biogas and with better quality, which is very beneficial for water treatment plants, and Diastate really complies with the Royal Decree about fertilizers and the conditions of its application in the soil. From the process perspective, having a biodegradable material well prepared and well hydrolyzed in digesters allows to have more stable production. The stability of operation is the biggest highlight. It allows for organic load constantly because these plants usually suffer from seasonality and from different organic loads per year. and that allows us to have an additive to neutralize without problems. And last, from the industrial perspective, these are plants that have a deficit. They exist, and even though we need to build more, we already have some, so it'd be great to take the substrate to existing plant who have a capacity deficit, and they also have an energy deficit. And this allows for self-consumption, and these plants can also generate a surplus that could perfectly be injected into the network. So to finish, since Econward, or from Econward, we see that the future biomethane entails building more plants, but also availing of the structure and infrastructure available in Spain and in the water treatment plants. And if you wish to speak about this for more than 10 minutes, we're at stand 271. And thanks so much for coming. Thank you, Pedro.